Okay, so our next app here reminds me that it's a perennial favorite of full stack student final projects to work on a meta project, something that has to do with code itself or with teaching code. This next application really demonstrates that and shows how developers love making dev tools. They applied it to one of our linchpin technologies, so I'll hand it over to Synq.
Good afternoon. My name is Kang, and my lovely teammates are Doris Cheng, Elisabeth Seite, and David Ko. And together we worked on Synq. Synq was created on the premise that database models and their many associations can quickly feel like navigating through a convoluted maze. Our solution was a lightweight desktop app built on Electron that helps you to visualize and create your Sequelize databases. It operates by running scripts that read the local and Redux states that you control with the GUI. Once you're satisfied with your tables and relationships, you can inject the files containing the Sequelize code right into your desired directory. Additionally, Synq can also generate seed files for you. It does so by running algorithms that we developed to determine the seeding priority based on the existing associations. Now I'll hand it over to Doris, who will give you a more in-depth demo of how our application works.
Thank you, Sun. To start things off, users first drag an undefined model from the sidebar into the canvas. You can click into a form to add additional model information, such as the table name, the table columns, and table validations. You can add as many table columns and validations as you would like. After saving the model, the card will be updated with the new information. If there is more than one card on the canvas, you can form relationships among the models. You can choose a type of relationship as well as the name of the table you would like to form the relationship with. The type of relationship will always be displayed near the source table. When you're satisfied with the structure of your database, you can enter the path of your project directory and press Create Files. This will generate a file for every Sequelize model that you create, as well as a complementary seed file. And now I'll pass the mic over to my teammate Elisabeth, who will talk about some of the challenges we face.
Thank you, Doris. The core of our application relied on our ability to take an input from the user, store it, and then process it to create Sequelize files. In order to do this, we started our project by defining the optimal architecture to store the user's work. It had to take into account any number and all types of input, input, as well as the structure of Sequelize models, columns, validation, and their nested nature. We also took into account available front-end technology and how we may receive input from the user, as well as how our data could then be read and parsed by an algorithm. To do this, we used React, Redux, and React drag and drop on the front end to create our user interface. React allowed us to create a highly modular user interface, while Redux provided us with a robust and compatible storing system. We then created our own custom algorithm on the backend to generate Sequelize files. Starting with the structure of our data allowed us to build our application in a consistent way with no discontinuities between our front end and our back end. And now I'll pass it over to David, who will tell you more about our background scripts.
Thanks, Ellie. So how our generator function works is that it is comprised of a host of pure text functions that take in user input, parse through that input, and outputs raw Sequelize code in a file format in the directory that the user selects. So we try to keep our functions as modular as possible in order to make debugging and creating tests a lot more fluid. And we also limited the repeating lines of code. Another challenge that we faced was during seeding, we needed to populate the models in the right order, or else we would run into a foreign key constraint error because of the dependencies that certain tables have to each other. And so how we dealt with this was we had an array of all of our models, and we iterated through our associations Redux state, and for each association, we looked at the two models that were involved, and then we reordered our array based on the associations that they had, if that was necessary. And that's how we tackled our final challenge. That concludes our presentation. We are Synq. You can check us out at our GitHub link below, and you should definitely try out our application. It will make your future interactions with Sequelize a much more pleasant process. Thank you, guys.
All right. If you're into database sync tools, vote for this team. Like the post, like the pinned comment. You know, I never tire of seeing students try this project because I feel a little bit like it's kind of like a Grail quest, right? And that developers have dreamed about not writing nice tools around databases for a long time, but it's difficult, and you know, a lot of interesting things they solved around kind of how do you keep the modules tight, generate the files, and do the seeding order. I'm curious if they got to situations where there's like complex graph networks of dependencies, but it's a clever solution for solving the foreign key thing for seeding, which is a known challenge. But I never tire of seeing that kind of project done. So very well done, very cool.
Thanks, Dave. I have to admit a certain amount of selfishness with this project because when people were looking for ideas, I was having myself the idea that I was going to work on some sort of topological graph sorting dependency seed generator. And I said, why don't you make that a stretch goal and I'll check in on you in a couple weeks. So I'm glad that I can offer some of my to-dos onto students.
It's like those situations where a professor's like, why don't you solve this problem? And you're like, oh, and it's like you find out it's like an unsolved problem. And